Diode have 0.7 volt drop. Then how we get 16 volt from 12 volt AC transformer after rectification? Inductor wanna filter the noise in the circuit, but also cause more current lag behind voltage. Hey everyone, welcome back to Voltage Vision. Today, we're uncovering the secrets of the most important electronic components, things nobody really tells you, but every beginner, hobbyist, and even pros should know. We'll go through resistors, capacitors, diodes, transistors, inductors, and LEDs. Not just what they are or their common uses, but the hidden truths, myths, and simple roles inside circuits. So grab a notebook, and let's get started. 1. Resistors. In most metal film resistors, resistance actually increases with temperature, compared to their fixed value. A resistor opposes the flow of current, and as a result, it drops voltage. This means voltage is always lower on one side of the resistor than the other. That's how it converts electrical energy into heat. 2. Capacitors. In DC circuits, capacitors in parallel are used for bulk filtering and decoupling. But if you connect them in series, they act as AC coupling capacitors, very useful in audio amplifiers. Here's a myth: many think bigger capacitor equals smoother circuit. Actually, in high-speed circuits like ICs, we need small-value capacitors because they charge and discharge timing super fast. Different capacitors have different jobs: electrolytic high capacitance, power filtering, ceramic high-speed decoupling. But capacitance value changes with temperature. 3. Diodes. A diode has a 0.7 volt drop. Because diode require a certain amount of voltage to even open the door and let the current. But here's a puzzle. How do we get 16 volt DC from a 12 volt AC transformer after rectification? The answer is 12 volt is the RMS average of transformer, but the peak voltage is -17 volt. After subtracting 0.7 volt diode drop, we get -16.3 volt DC at the output. For dot transistors, NPN transistor, current flows from collector to emitter. The base must be about +0.7 volt higher than the emitter to turn on. Example, if emitter 12 volt, base must be at least 12.7 volt. PNP transistor, current flows from emitter to collector. The base must be about 0.7 volt lower than the emitter. Example, if emitter 12 volt, base must be around 11.3 volt. In both cases, remember, without proper base current, the transistor stays off. 5. Inductors. Inductors are used to filter noise and give smoother current paths. But here's the truth: they also cause current to lag behind voltage in AC circuits. Real inductors aren't perfect. They waste power as heat, copper and core losses, and their magnetic fields can couple into nearby circuits, creating unwanted noise. 6. LEDs. Notice how higher wattage LEDs have shorter lifespans. That's because more current equals more brightness, but also more heat, shorter life. LEDs convert electrical energy into light, photons. But in reverse, if you shine light on an LED, it can generate a tiny voltage, 1.5 to 2 volt. Not enough to power devices, but useful as a light sensor. These are the bonus myths: transistor, MOSFETs, thyristor is hybrid of diode, and, or, not etc. All types of gates are combination of transistor. Solar panel is a group of p-n junction diode. And that's it. The hidden truths of the 6 most important components in electronics. If you found this video useful, don't forget to like, share, and subscribe, and join me next video of electronics here on